Good afternoon, everyone. Let us start this session. So in the previous session, we have seen this problem where three forces are given, F1, F2, F3. One force was unknown, which was F4, and the resultant was given 800 Newton. Okay. So from this given information, we calculated the unknown force, which is the fourth force, F4. So this is the X component of that force, and this is a Y component. So from these two components, we can find out the net force, which is the F4. Okay. So to calculate this force F4, you can use this formula, square root F4 x square plus F4 y square. Okay. So it is the same formula that we use to find out the result. Okay. Only in case of resultant, your formula will be R is equal to square root summation fx square plus summation fy square. Okay. And to find out this force F4, we have to consider the x component and y component. So get this value. So here F4x is 741. So 741 square plus this is minus 612. So you can directly consider 612 square equal to and take the square root of answer. Okay, so your answer will be 961.05. Okay, so this is the net force, which is a F4. Then this is the direction of that force. Okay, so I think you calculated the direction in the last lecture. So that direction was 39.55 degree with respect to positive x-axis. Okay, so now for the next problem. So here we have to find the fourth force F4 completely so as to give the resultant of the system, which is as shown in the figure. Okay. So here resultant is given as a R 150 Newton and the resultant, its angle is 45 degree. Okay. So in the system, actually there are four forces, F1, F2, F3 and F4. So force F4, it is not given. Okay, similar to the last problem. For this four forces, the net effect, that is nothing but resultant, this is equal to 150 Newton. Okay, and that 150 Newton, it is shown in the diagram. And we have to find out what is the unknown force, which is a F4. Okay, so I will redraw the figure. So here we will assume 100 Newton as a first force. So this is your F1, okay, which is equal to 100 Newton. Its angle given with respect to y-axis. So this is 30 degree. Second is 120 Newton. So this is a F2, which is a 120 Newton. Its angle is given with respect to x-axis, that is a negative x-axis. So it is a 60 degree. Next is 250. So this is a F3. Okay. and its angle given with respect to negative y-axis, that is equal to 25 degree. And these are, so this is not the force out of that four forces, it is the resultant. So this system, this is called as a system of forces. Okay, it is equivalent to the resultant system. So if you want to draw the resultant, so this is the resultant, that is a net effect by the four forces, which is R, and its angle is 45 degree with respect to positive x-axis. Now in this system, one force is remaining. Okay, so that is the unknown force. So you can assume the unknown force anywhere. So I will assume this unknown fourth force in the first quadrant. Okay, and assume the angle as a theta 4. Okay, so now this is the system of forces and this is the resultant. Now question is, we have to find out the magnitude of the unknown fourth force, its direction, that is a theta 4. So your first step will be, we have to resolve the forces. So resolve the forces F1, F2, F3. Okay. So consider F1, select a point. Okay. Now observe the direction for F1. So this is the X component and this is the Y component. Okay. This angle is 30 degree. So this angle will be 30 degree. So for the F1, its Y component. So this is a F1Y. This is equal to, so this is the cos component because F1Y is adjacent to angle 30 degree. So this value will be 100 cos angle is 30. Okay. Its X component, which is a F1X. Now this is opposite component to the given angle 30 degree. So this will be sine component. So this is 100 sine 30. Okay. So whenever you show the component directly on this diagram, do not give the sign. Okay, because this vector, it is already in the negative x direction. Okay, so you cannot give the negative sign in the negative direction. So just write this value positive. Okay, because we know the direction, and whenever you will use this value in your calculation, that is for summation fx or summation fy, then give the proper direction. Okay. Similarly, resolve the F2. This is the X component and this is the Y component. Okay. Here angle 60 degree for F2, it is with respect to x-axis. So this angle will be 60 degree. So this is F2x. So F2x component, it is the adjacent component. So it will be cos component. So force is 120 cos 60. And this is the Y component. So this is F2y. This is equal to 120 sine 60. Okay. Don't give negative sign because F2y is already in the downward direction. Okay. In the calculation, you can give the sign. Then F3. So this is F3x. And this is F3y. Okay. Now this 25 degree, it is with respect to y-axis. So this angle will be 25 degree. So F3x will be opposite component to the angle 25 degree. So this is sine component. So 250, that is the F3 value, sine 25. So this is the F3x and this F3y. So this is equal to 250 cos 25. Okay. Actually, the component is negative. It is in the downward direction. Okay. but don't give the sign whenever we write the equation or component in the diagram. Okay. Now you can write the equation summation fx. Okay. So what is summation fx? Summation fx is nothing but x component of result. Okay. And this is equal to, now observe the result. So this resultant, this is equal to 150 Newton. So this is the x component of resultant, which is Rx. And this is the y component of result. So this is a Ry. So Rx is equal to 150. It is adjacent to 45 degree. So it is a cos 45. And Ry is equal to 150 sin 45. Okay. So Rx is 150 cos 45. And summation Fy is nothing but Ry. And Ry is equal to 150 sin 45. But observe the direction for Ry. So Ry, it is in the negative y direction. So we will use minus 150 sin 45. Okay. So this is your first equation. And this is second equation. Now we have to write the equation for summation fx and summation fy by observing this diagram. That is a system of forces. Okay. So we have to resolve this F4, which is the unknown force. So this is F4x and this is F4y. So now write the equation for summation fx and summation fy. So summation fx, this is equal to, start from f1. What is x component for f1? It is 100 sin 30 on negative side. So it is minus 100 sin 30. Okay. Next component is f2. 120 cos 60. Again, it is negative. So it is minus 120 cos 60. Okay. Next is f3. So f3x 250 sin 25. So plus 250 sin 25. And the unknown force, which is f4x, it is on the positive x side. So plus f4x. Okay. So summation fx is nothing but this value. So we can equate this complete equation. So this is equal to 150 cos 45. Okay. And then calculate the value f4x. So f4x, you will get some answer for f4x. Okay. So calculate this value f4x. So your equation is 150 cos 45 then minus this 250 sin 25 and plus 100 sin 30 plus 120 cos 60. So 110.41. Okay, so this is the value for f4x, that is the x component of force f4. Similarly, find out the summation fy. So write the equation for summation fy. So for summation fy, this is the first component, which is 100 cos 30. Second is on negative side, so minus 120 sin 60. Third is also negative, minus 250 cos 25, okay, and plus f4y. So this summation fy, it is equal to the y component, which is a minus 150. So this is minus 150 sine 45. And from this equation, find out the f4y. You have to find out this value. So f4y, this is equal to so it is minus 150 sine 45, then plus 120 sine 60, plus 250 cos 25, and minus 100 cos 30. So summation fy, sorry, f4y is 137.83. Okay, this is 137.83. This is again in Newton. Okay, so now we have got two components for force F4. This is F4y and this is F4x. Okay. So finally, we can find out the net value of F4. I think both the components are positive. So F4x, this is 110, and F4y, this is 137. This is 137.83. So what is meaning this positive? F4x on the positive x side and F4y is positive y side. Okay. So from this we can decide the quadrant for F4, which is an unknown force. Its quadrant is first quadrant. This is a F4. And its magnitude we can find out. F4 is equal to square root F4 x square plus F4 y square. Okay, so calculate this answer. So this is 110.41 plus 137. So it is 176.59. So this is the unknown force, which is the F4. Okay. Now its angle with respect to x-axis, which is a theta 4. So theta 4 you can find out as, so actually this is F4x, this is F4y. Okay. So this is equal to tan inverse F4x, sorry, F4y upon F4x. Okay, so in the numerator always take y component so that this angle it will be with respect to x-axis. So this is equal to tan inverse, put this value. So this is shift tan so it is 137.83 upon 110.41. So angle is 51.3. So this is 51.3 degree. Okay, so now you can show the force in the original diagram. So actually, our assumption is correct. We have assumed the force F4 in the first quadrant, and finally, from the calculation, we get the same quadrant. Okay. So this is the position of the unknown force F4, and this is the angle theta 4. Okay. So I hope we have understood this problem. If the system of forces is given and one of the force is unknown, then how to find out that unknown force from the given resultant value. Okay, so refer this next problem. So in this problem, a car is being pulled by two forces. One is FA and FB. So actually, two cables are connected at the ring O, and forces in the cables or the tensions are FA and FB. Okay, so FA is 750 Newton and its angle is 45 degree with respect to this y axis, and FB is 800 Newton and its angle is 30 degree. So this problem we can solve by using law of parallelogram or by summation fx and summation f1. Okay. So the condition for law of parallelogram is we can use this for concurrent force system. And the second condition is there must be two forces. Okay, then we can construct the parallelogram and we can find out the resultant directly by law of parallelogram. So I will show how to solve this by using this law of parallelogram. You can try this by regular procedure, summation fx and summation f1. Okay, so for law of parallelogram, if this is the point O and this is one force P and this is the second force which is a Q. Okay, and this total angle between two forces is alpha. Then resultant we can find out by constructing the parallelogram like this. So draw one vector parallel to P, draw second vector parallel to Q. Okay, so this is the diagonal which gives the resultant of these two forces, and this is the angle of resultant with respect to one of the force, that is a P. So formula for this resultant R, this is equal to the square root P square plus Q square plus 2PQ cos of alpha. Okay, alpha is the angle between two forces P and Q, and angle of resultant, or we can say this is the direction, theta is equal to tan inverse. This is Q sin alpha upon P plus Q cos alpha. Okay. So when we use Q in the numerator, we will get this angle theta with respect to P. Okay. And if you use P in the numerator, then you will get the angle with respect to force Q. Okay. So by using this formula, we can find out the resultant for this given system. So here, this is the first force, which is given as a FA. Okay. So we can assume this force FA as a Q, because we will refer this formula. Then this is the FB. So take this force as a P. Now from these two vectors, construct the parallelogram. So draw parallel line like this. Then this will be the diagonal, which is the resultant arc. Okay. So right now we don't know whether the resultant is exactly along x-axis or it is upward or downward. Okay. So here force P, which is nothing but the FB, and this is equal to 800 Newton. Force Q, which is equal to FA, which is equal to 750 Newton. So it is given here in the statement 750. Theta 45 degree. So don't get confused with this theta. Okay. So theta means this angle is given with respect to y-axis. So this total angle, we require the alpha angle between the two forces. So alpha is equal to, so this is 45. So this will be 45. So total angle will be 30 plus 45. So alpha is 75 degree. Okay. So from this information, get the value of R, which is square root 800 square plus 750 square. Okay, so find out this answer, resultant. So unit will be Newton. And then calculate the value for theta, that is the direction of resultant with respect to force P. Okay, if you use this formula, you will get the theta with respect to P. Check the answer, resultant R, which is 1230.07 Newton. And this theta will be, this is tan inverse. So force Q is FA and its value is 750 sine 75 upon P is 800 plus 750 cos 75. So for this, you can use shift tan inverse. You can use this fraction. Okay. First value is 750 sine 75. Then in the denominator, it is 800 plus 750 cos 75. Okay. Then press the right arrow and complete the bracket. Then equal to. So angle is 36.082. Okay, so this theta angle, it is with respect to force P. If you refer this diagram, okay. So here this is the force P. So now observe the original diagram. Okay, so this 30-degree angle, it is given with respect to x-axis. Okay, and what is the angle for resultant? It is 36.082. So your original diagram was like this. So this was the FB. We assume this as a Q. Then this is FA. So this is P. This is your reference axis. So this is the x-axis. And this is the y-axis. Okay. So if you construct the parallelogram with proper dimension, then resultant it will be just above the x-axis, like this. Okay, so this is the resultant. And this total angle with respect to force P, this is theta, and this is equal to 36 degree. And in the diagram, 30 degrees given. So this angle is given for the force P with respect to x-axis. So this angle is given as a 30 degree. Okay. This angle is given as a 45 degree. So angle between these two forces we use as a alpha. So this is equal to this 30. Okay. And this is 45 degree remaining angle. So this is 30 plus 45. So it is a 75 degree. Okay. This is your force Q and this is R. So you can draw this diagram. Now the same problem, you try to solve this by summation fx and summation fy. Okay, and check the answer for resultant, whether you get the same answer. So you must get the answer as 1230.07. Okay, so rejoin the link.